Hey guys, today we are going to move on to the next section, which is 8.5, adding and subtracting rational expressions. Um, now, I want to preface this by saying that this is definitely not one of the easier quote unquote topics. Um, and a lot of the reason for that is because when we're adding and subtracting rational expressions, essentially what we're working with is fractions. And, fractions is a area where it can be similar to factoring, where some people feel pretty good about it, may actually enjoy it, and some people are on the flip side and don't like dealing with fractions. And so um, that's usually, though, where the hiccup or the gaps may occur if you're struggling with this, is because it's the concept of adding and subtracting fractions. So to start there, and again, these notes are going to be like yesterday's. We're definitely not going to do all these problems. Um, but I do want to run through a handful of them. So the notes, the steps are up here. I'm going to kind of walk through them as I do them. But a couple things to write on the side here. Um, let's just kind of talk about fractions without variables, so non-rational expressions. So if we just had 3 over 7 plus 1 over 7, you guys would probably know, okay, well, in order to add fractions, you have to have the same base. Well, we do. They're both, I'm sorry, the same denominator. So they're both 7, so we're good there. So you keep the denominator the same, but then you add the top, so it's 3 plus 1, so we get 4, right? Now, what happens if we change that and now we do 3 over 7 plus, say, 4 over 3? Well, this is where we'd have to talk about a common denominator. And generally, we want it to be the least common denominator. So that's a concept we're going to use a lot today. The least common denominator between 7 and 3, most of you know, is going to be 21. So then what we do is, in order to get to 21, we have to um, manipulate each term. The first term, to get from 7 to 21, we need to multiply by 3. So whatever you do to the bottom, you have to do to the top as well, right? And then for the second term, to get from 3 to 21, we need to multiply by 7. So we do it like this. So then what happens is we work that out. 3 times 3, we get 9 over 21. Sorry, let me change back to red. And then in the second term, 4 times 7 is 28 over 21. And now we have the common denominators, so now we can add those. So the denominator is 21. And then we add the top, 9 plus 28, and we'll get 37. Okay, so using that concept of least common denominator is what we're going to do today. But now it is going to be more difficult because we're going to add in variables. Okay, and the other thing that makes it a little tricky is we're also going to add in some factoring. So this topic, the reason it is so challenging is because it has two of some of the more challenging topics and ones that we struggle with, and that a lot of us don't look forward to, which is fractions and factoring. So let's look at number one to start with. This is a pretty straightforward example because the bases are the same, right? 4a squared, we don't need to do anything. So what we would do is we would just add the top. So really it's 13a plus 5a divided by 4a squared. Well, we can combine the top two because they're like terms, and that is 18a over 4a squared. But then we can reduce that. 18 divided by 4 is going to reduce to 9 over 2. Let me rewrite that just so you can tell that's a 9 and not an a. I don't know if that was much better. And then the a over a squared, um, one of the a's cancel out, leaves an a on bottom. And so this is our final answer. Okay, now let's throw in something slightly different. Let's go to the next one right below it, number 3. So again, this is still like base, but the difference here is um, we're going to end up having to factor in order to simplify. Okay, so right now, same base. So what we can do is we can combine like terms, um, meaning we can add all of that across as 1. Okay, so it's going to be y squared plus 2y, sorry, plus 10y. Let's just go ahead and add those, plus 21 divided by, now let's factor this. Okay. Actually, let's not factor it quite yet. Let's just keep it as is. And now let's factor it because in order to be fully simplified, we need to make sure um, that we've canceled out any common denominators or common factors in the top and bottom. Well, in order to know common factors, you have to factor it. So the top is going to factor to y plus 3 times y plus 7. The denominator is going to factor the difference of squares, so it's going to be y plus 3 times y minus 3. And now we see our common factors. So we cancel those out, we simplify, we're left with a final answer of y plus 7 divided by y minus 3. Okay, so recall what we did right here is we factored. And again, the reason why we did that is we want to see if there's any common factors between the top and the bottom. Okay, I'm going to pause the video. I want you guys to try number 5 that's on this worksheet, which is one right below it, and then we'll come back. Okay, so number 5. Again, same base, so we're good there. We don't need to find any common denominators. So let's just combine the top. Now, hopefully you saw this negative here, right? So I like to think of it as, put that in parentheses, this negative needs to be distributed to each of these. So really on top, we have n squared plus 3n minus 7 minus n minus 1. And on the bottom, n squared plus n minus 6. Okay, so let's combine everything on top. We'll combine like terms. We're going to have n squared plus 2n minus 8, and on bottom, n squared plus n minus 6. And now let's factor to see if we have any common factors between the numerator and denominator. The top is going to factor to n plus 4 times n minus 2. The bottom is going to factor to n plus 3 times n minus 2. We have a common factor in n minus 2, cancels out. What are we left with? N plus 4 divided by n plus 3. Okay, so hopefully you were able to get that one. All right, now before I move on, one thing I did want to address, some of you guys might be thinking about is, do we need to worry about restrictions like we did on yesterday's lesson with multiplying and dividing rational expressions? And the answer is yes. However, I'm not going to worry about that today, okay, because we're probably going to do more practice on this tomorrow. And right now I want you to focus more on just adding and subtracting these and then worrying about restrictions later, okay? All right, now what happens when it gets a little trickier? When your bases are not the same, okay? And this is where the bulk of the work is going to be. So we're going to look at number 7 on this sheet, which is the one right below it. So first thing is we look at our two denominators. We have a 2x and a 3x. So what we want to do is find our LCD, okay? So the least common denominator. So start with just, in this case, just start with the numbers. The least common denominator between 2 and 3 is 6. Most of you guys see that. Least common denominator between the variables is just a single x. Okay, you don't need to do x squared because that's not the least common, right? Each one has an x, so it covers both of them. So what do we need to do in order to get that 6x? Well, we need to multiply this one by 3. So it's 3 over 3 because remember, like we did in this example over here, if you're multiplying a term in order to get the least common denominator, you have to multiply top and bottom. All right. And then over here, we're going to multiply this by 2. All right. So when we do that, we're going to get 45 over 6x. And then 16 times 2, so we'll get 32 over 6x. Well, now we can combine that 45 minus 32, and we'll get 13 over 6x. We can't simplify it any further, so that is our final answer. Okay. Let's go ahead and just move on to the next one on the next page. Okay, so now it's going to get a little more complicated. And so what I actually want to do on the left side here is write out steps as we're doing this, okay? So first step that we are actually going to do is you want to factor. and that's if possible. Because you could see on the previous one, we didn't need to. So, and the reason why I want to factor is that that's going to help us determine our least common denominator. It's hard to see the least common denominator if you're not in factored form. Okay, so this factors to, if you take out a 5, you're left with k minus 2. And then the other denominator doesn't factor at all. Okay, so what is next step would be determine your LCD. Okay, and so this is how I kind of do LCD. So I look at the denominator of each and I do it separately. So denominator of the first term, I have a 5, so I need a 5. And then I have a k minus 2, so times k minus 2. Okay, and then I go to the second term. The second term has a k minus 2. Well, I already have the k minus 2, right? Because it's right there. You don't need to put it again. Okay, you don't need to put it again. Now, if the second term was k minus 2 to the quantity squared, then yeah, then I would have to put another k minus 2. But since it's only k minus 2 once, I already have k minus 2 once, so I'm good. Okay, so there's my LCD. All right, next step. Now it's just like working with fractions. Multiply each term by, and I'm going to put 1 here, because whatever you multiply by the bottom, you have to multiply the top. And again, the reason why is we don't want to change the integrity of the terms, right? And we multiply by 1, it's not losing its value, okay? We're just not going to multiply by the actual number 1. We're going to multiply by a number expression over itself, okay? So multiply each term by 1, whatever you need to get the LCD, the least common denominator, on each. And that might not be worded the best, but hopefully you know what I mean. So I'm going to just rewrite it here because it kind of gets a little messy here. So the first term, the original is k squared plus 16 over 5 times k minus 2. So what do I need, right, so that this becomes this? Nothing. That already has the least common denominator, so I'm good there. All right, let's look at the second term. 4 over k minus 2. Now I need this to be the yellow. And so what I'm missing is a 5. So I'm going to multiply top and bottom by 5. Okay, and so now I'm going to have k squared plus 16 over 5 times k minus 2 minus 4 times 5 is 20 over 5 times k minus 2. And now it looks pretty good because I have common denominators. Okay, so now the next step is going to be kind of a combination of stuff here, right? Multiply slash simplify slash combine, right? It's a little bit of everything depending what your terms look like. Basically, I have the same common denominator, so now I can actually subtract them. Okay, so now I'm going to have k squared minus 4 all over 5 times k minus 2. Okay, now what I need to look here, and it's not going to be specific in my notes on the left side, is I need to make sure that I'm fully simplified. In order to do that, I need to refactor. Okay, so here I'm going to say simplify, and I'm going to say specifically cancel out common factors. So this becomes, the top is k plus 2 times k minus 2. The bottom is already factored out. And now we can see there is a common factor, so we cancel that out. And our final answer now is k plus 2 divided by 5. Okay, so again, the premise and the foundation we're working here is with fractions. It gets more complicated because we're adding in the variable. That's what makes it a rational expression. And then it gets more complicated because typically at some point or multiple points in the problem, like in this one, you have to factor. All right, I want you to try number 11. when the video pauses, and then I'll go over it. Okay, here's number 11. Let's follow our steps. First one is a factor. And at this point, I'm only going to worry about factoring the bottom because the reason I'm factoring is to determine the LCD. So I'm not going to factor the top at this point. So if I factor the bottom, this is x plus 3 times x plus 2. Okay, the second term is already factored. So let's figure out our LCD. So again, I look at the first term, I need an x plus 3 and I need an x plus 2. All right, second term, I need an x plus 2. I already have it. Do not repeat it again. You do not have to repeat that. Okay, so now, next step is multiply each term so that you have the LCD on each one. So turns out the first term already has the LCD, so we don't need to do anything. So the first term stays as is. The second term is going to need some manipulation. Okay, so the second term does not have the LCD. So we need to multiply the second term by what's missing, right? What's missing is the x plus 3. So we need to multiply top and bottom by x plus 3. And again, the x plus 3 over x plus 3 is the quote-unquote 1 that I wrote in step 3 on the side, right? We're multiplying by, we're manipulating it, we're multiplying by 1, but it's not actually the number 1, right? An expression over itself. Okay, let's go ahead, multiply this out, subtract all that, or add all that good stuff. Now we're going to have x squared minus 5. And then what I'm going to do in this step is what a lot of you guys are going to see you can do is I can just go ahead and do everything on the top line together, right? So meaning x squared minus 5 plus, I'm distributing this, which is just a 1, so it's going to be plus x plus 3 all over. Now both terms have the same denominator, x plus 3 times x plus 2. All right, combine like terms on the top. So we have x squared plus x minus 2 over x plus 3 times x plus 2. All right, and now we're at the point where we need to make sure that we simplify this, which means that we have to look to see if you can factor. And you can factor the top. It becomes x plus 2 times x minus 1. Bottom is already factored. Look for common factors. You have an x plus 2, cancel it out. So fully simplified, you're left with x minus 1 divided by x plus 3. Okay, and so in that case, we did have to factor twice. We had to factor at the beginning to help find our LCD. We had to factor again at the end to make sure that we were fully simplified. All right, guys, so hopefully that one went okay. Let's do one last set here. And these are probably the hardest ones that you'll see through this section. Okay, so first step, factor. This is take out a 4. I'm left with p minus 5. Over here, this is going to factor to p minus 5 times p minus 3. So LCD, see I need a 4, I need a p minus 5, I need a p minus 5, I already have it. I need a p minus 3. Okay, now I'm just going to erase that for my purposes here. Oops. Let me do a better job. Oh, struggling here. Okay, now that I know what my LCD is, I need to figure out what I need to multiply everything by. So I'm going to try to do this without having to write it out again. What's missing from the first term? It looks like p minus 3 is missing, right? So you need this to match this, and you need that to match that as well. So in the first one, p minus 3 is missing. So I'm going to multiply top and bottom by p minus 3. And the second term, what's missing is the 4. So I'm going to multiply this by 4 and a 4 down here. Hopefully that makes sense to you guys. So what I end up getting on the top is 2 times p minus 3 plus 4 times p minus 6. And now I have a common denominator at the bottom, which is 4 times p minus 5 times p minus 3. Okay, and hopefully you see I'm just not writing every single step out now. All right, distribute, combine like terms, all that good stuff. We're going to have 2p minus 6 plus 4p minus 24 all over 4 times p minus 5 times p minus 3. Now, notice I'm not multiplying out the bottom. I don't want to do that because remember, our last step is to always see if there's any common factors. So I don't want to multiply the bottom out because it's already factored, right? Combine like terms on top. You're going to get 6p minus 30 over 4 times p minus 5, p minus 3. Factor the top, take the GCF of 6 out. You're left with p minus 5. Bottom stays the same. And now I'm in factored form, common factors, p minus 5. So finally, get to my answer. I'm going to reduce these two. 6 over 4 reduces to 3 over 2. So I have a 3 on top, 2 on bottom, times p minus 3. Okay, last one, guys. Try number 16 on this sheet. When you come back, I'll go over it. All right. So let's just walk through these steps again. First step, factor. Okay, this, take out a 2, r plus 4. Here, take out GCF of r plus 4. Second step, find your LCD. So I need a 2. I need an r plus 4. I need another r. I already have an r plus 4. All right, so let's figure out what we need. So again, I need this to become this, and I need that to become that as well. So what am I missing? Let's see, from the first term, it looks like I'm missing an r. So what I'm going to do is I'm going to multiply this by r and this by r. In the second term, I'm missing a 2. So I'm going to multiply this by 2 and this by 2. Actually, maybe it will make more sense to you guys if I put it down here. I'm going to multiply this by r and this one by 2. Okay, so what do I get? First term, I have r times r, so I have r squared. There's a minus sign there that I wrote over, and then 8 times 2, 8, 16. On the bottom, my least common denominator is what I determined it was as my second step, so I'm just going to rewrite it a little bit. Is 2r times r plus 4. Okay, factor the top. So you can see if there's anything that'll cancel out. The top is a difference of squares. It factors r plus 4 times r minus 4. And what that does is that cancels out our r plus 4, top and bottom. What are we left with? R minus 4 on top, on bottom, 2r. And there we go. So recognize that this is one of the challenging ones, which is why we're probably going to spend another day on it tomorrow. But hopefully this made some sense to you. Give the homework a shot, and we'll go from there. Thanks, guys.